I still have some questions. They're not really hard. I mean, at least you know you're thinking. It's not just there. I'm learning them. Honestly, me too. Because whenever I'm in water, my head just floats. So honestly, I think there's a lot of variance. No, because listen, like I don't have to keep my head above the water. I don't have to like move it or anything. I just float. I don't sink.
All right. So the lab that you're going to do today, ladies and gentlemen, pretty much is going to take most of the hour. So we need to get going on it. Goggles are in the back in the box there. You will grab a pair when you head into the lab and you will put them on and you will keep them on while you are doing the lab. The lab is in Canvas, ladies and gentlemen, so let's take a look at it. It is a gas law lab. You are going to use ideal gas to find the amount of moles of a gas produced during this experiment. That is our goal, okay? So, to do that, ladies and gentlemen, to use ideal gas, we need to collect pressure, temperature, and volume to solve for number of moles. You will be able to do all three of those very easily in this lab. The other thing in this lab, you are going to do the procedure twice. So you're going to do it, dump everything out, do it again from the start for 2 trials. Okay? Now, what that means is when you get to the calculation section, ladies and gentlemen, at the end, it is set up for you to plug your numbers into the calculation. However, my rule is if you do the same calculation twice, you need to show me one example, and then the second time you can just do the calculation without showing me and show me just the answer for the second time. Now, your answers may be fairly close, and that's okay, all right? But understand, you don't need to show me the entire calculation over again. You show me it once with your numbers plugged in, and then you show me the second time for your second value, whatever calculation you did. We'll get to that when we get more into the calculations. All right. So, ladies and gentlemen, step number 1 is measure and record room air pressure and temperature. We don't really need the room temperature, so we're going to skip that part. But for the room air pressure, ladies and gentlemen, here it is. 99 point, which one do you want? 19 or 25? What? 25. All right. So today's air pressure is 99.25 kPa. You are going to need that for your lab. Okay? You are going to need that for your lab. So you can go here into this table, and under room air pressure, you can type in that number for both trial 1 and trial 2. Okay? Please remember to put units with it, otherwise you will not get full credit down there because there are no units in that table. So you need to put your units after your numbers. All right. All of the equipment that you see up here, ladies and gentlemen, is out at every lab station in the back. You do need to share the graduated cylinder with the other group at your table. There are these gas collecting tubes out at every station. They are in the middle of the table in between the 2 water containers. When you are done with them, please put them back there. They are there so that there is no way that they can fall off the table and break. Now, what is unique about this gas collecting tube is what do you notice about the numbers on here? I know you can't see. That's why I'm asking him. What's at the top?
The lower number.
And bigger numbers as you go down. This tube is designed to collect gases. Gases will rise through this tube and collect at the top. This allows you to measure them. So your gas collecting tubes are the same way, ladies and gentlemen. Okay? Ooh. Hang on a second. Yeah, that ain't gonna work. Hold on. I'll be back in 1 second, ladies and gentlemen. Sorry, ladies and gentlemen, my gas collecting tube is a little bigger than the one you'll be using, so I needed a different stopper. Okay, so step 2, you're going to get a piece of magnesium ribbon. They are already cut and sitting by the balances in the lab. But this part is very important, ladies and gentlemen. Do not use any piece of magnesium that is over 0.045 grams. Because if you do, you will produce more gas than the gas collecting tube can measure, and you will have to start all over again and throw out all your results thus far. So make sure that when you grab your piece of magnesium and put it on the balance, if it is over that weight, please give it to me. I will trim it and pick a different one out of your tray. There are 20-some pieces of magnesium in there. Okay? So that is very important. By the way, this number will go down in that bottom table. That bottom table is where all of your numbers are going to go. So when you get the mass of the magnesium ribbon, you put it in here. You also need to make 3 observations of the magnesium ribbon. Those go in up here. What you see, what you feel, what you smell. Don't taste anything. And the magnesium ribbon should not be talking to you. Okay? So, observations up here. Now, for this next part, ladies and gentlemen, we are going to need the magnesium ribbon to be held in place by a copper wire. So it says fold your magnesium ribbon in half and wrap it in a copper wire cage. The cage should hold the magnesium ribbon in place and yet allow the hydrochloric acid to get to it. So here is what I mean by that, ladies and gentlemen. When you get your piece of magnesium ribbon and you are sure that it is not more than 0.045 grams. Okay. You're going to take and you're going to fold it in half, but do not crimp it. If you push it flat, you will break it along where you have folded it. I just made it like a little U. I know that is difficult to see. Let's see if I can help. So it is shaped kind of like a U. Okay? You have a piece of copper wire at your lab station. You're going to take and put the copper wire right in the middle of the U in your magnesium ribbon. And then you are going to wrap it around a few times to hold the magnesium ribbon in place, just like that. Okay? That's all you needed to do. Just hold it in place when you start the lab. So all I did was put the copper wire through the middle, wrapped it around a few times. Okay? Just to hold it in place. Okay? All right? Again, if you squeeze the magnesium ribbon, it will break into 2 pieces and it will be harder to wrap up, which means you either then need to get a new piece of magnesium ribbon and record the mass, or you need to do something. Guys, Ethan, on me. You're about to do a lab. Whatever video you're watching isn't that as important. That's what I'm doing. Okay? Set this off to the side, ladies and gentlemen. Okay? Now you can make your observations of your hydrochloric acid. The only thing that is out at your station in the beakers is the hydrochloric acid. So again, make your observations of them. Hang on, I better put my goggles on for safety, ladies and gentlemen. All right. So again, you're just going to make some observations. Don't touch it. Now, it is not as concentrated as the hydrochloric acid you have used before, but it is still concentrated enough to where it will burn your skin. If it gets into your eyes, it could cause permanent damage. So again, you need to be cautious with it. Do not touch it. Observations: what you see, what you smell, do not feel. Do not taste. Do not listen to it. Okay? So, those observations, ladies and gentlemen, again, go over here. You need 3 minimum. Now what you are going to do is you're going to put about 20 milliliters of hydrochloric acid into a beaker. The markings on this beaker are fine because this is an approximate amount. Does not have to be exact. So I'm just going to take and pour about 20 milliliters into my beaker, and then I am going to stop. Okay? Now, Jesus, can you give me a hand here? Sure. I need you to go back and grab a pair of safety goggles, though. Okay? And I'm going to need a hand in just a second. Come on back here. Oh, he's got his own. That's awesome. Take your gas collecting tube. Come on back on this side, please. You're going to pour your 20 milliliters of acid in there. Okay? Now you are going to take your container, your beaker, reach into the bucket, and you are going to completely fill this all the way to the top with water. And when I say all the way to the top, as full as you can possibly get it. Okay, can you hold that for me?
I hope so.
Okay, now,
Kevin, not now.
you're going to take and fill it. You need to get the temperature of the water inside the bucket that you just took the water out of. So turn your thermometer on. Please make sure it is reading in degrees Celsius because we can easily convert that into Kelvin. So you just lay that in there, get the temperature. Okay? Now, we have it filled. Go back and get your magnesium ribbon. And you are going to make a little hook on the other end of the magnesium ribbon. Just a little hook to hook onto the gas collecting tube so this doesn't slide all the way down into it. And what we're going to do is I'm going to take this. You got it? We're going to put it into there. And then I'm going to take and put my stopper, my one-hole stopper, on the top. Okay, I got it for now. You're going to take and turn it over upside down. Keep your finger on the one hole until you get it under the level of the water in the container. Now, what did we learn about putting an opening like the can underwater? It seals it, right? Okay. Right now, what is happening is that hydrochloric acid is working its way down to the magnesium ribbon. Can you go and slide on the right-hand switch there? There is a slider on the side. Can you slide it all the way up? Thank you very much, sir. So as that magnesium ribbon comes in contact with the hydrochloric acid, it will start reacting. And it is going to produce hydrogen gas. The hydrogen gas is then going to collect in this tube. And that is what we are trying to measure. The hydrogen gas that is created during this reaction. So it is just now starting to bubble. The magnesium ribbon is reacting with the hydrochloric acid. By the way, these are your last observations here. What you see happening in this reaction. You can describe how you see the the hydrochloric acid working its way down to the magnesium ribbon. You can describe what is happening to the magnesium ribbon right now. Okay? Now, you are going to let this continue until the reaction is completely done. How will you know when it's done? What do you think? How will you know when this reaction is done? How did we know when it started? We saw bubbles. When there's no more bubbles coming up. The magnesium ribbon will be gone. There will be no more bubbles. Okay? So right now, I am starting to collect gas at the top of this tube. It is forcing the water and acid mixture in here out of the hole at the bottom and into this container. Do not worry, this container is not going to become dangerous for you to put your hands in, because the little bit of acid that does escape is going to be so dilute that it will not matter. But as you can see, I'm starting to collect more and more gas. Okay? Can you hold this for a second, please? Just like this for me, please. Thank you very much. At this point, ladies and gentlemen, on this table, you should have the room air pressure, the mass of the magnesium, and the temperature of the water. Okay? Those are the things that you should have. Our bubbling is becoming more and more intense. We are collecting more and more gas here. Okay? And one person is stuck holding it this whole time. Okay? I got it. Thank you very much, sir. Now, listen carefully, because I'm going to answer things that are questions. You can go ahead and have a seat. Thank you, Jesus. All right. Why do we hold it under the water level? To seal off the gas. Now, as this gas is being created in here, any water that is being displaced here will go into here because of the pressure that this gas is creating. Now, I have no way of going inside here and measuring the pressure. Madison, I'm sorry if I'm boring you before you do a lab where you could hurt yourself. You could take the lab off if you want. Okay? So, my bubbling is slowing down. It is almost stopped. When it does stop, I'm going to tap it on the bottom a little bit, because any gas that is down there, I want that gas to come up and collect up here. Now, I can measure the volume now. I know the water temperature. The problem is I don't know the pressure inside here. I can't stick a probe up in there. So I have to find the pressure another way, ladies and gentlemen. I am going to what is called equalize the pressure. Please listen, because I'm answering a question for you in the lab questions. To equalize the pressure inside, I am going to take this tube and I am going to put it into here. Okay? I'm going to put it into here. And I am going to get the water level inside the tube and the water level in here to the exact same height. Because when the water level in here and the water level in here is the same height, the pressure of the gas in here will be the same as the pressure of the gas pushing on this water. Do we know the pressure of the gas pushing on this water? What is it? It's the 99.25 kPa. So we are going to what is called equalize the pressures. The pressure in this tube and the pressure here will be the same when the water level here and the water level here is the same. Now this is a little bit tricky part. Jesus, can you come back up? You can leave those off. We're done with the acid. Can you do me a favor? Can you grab that pitcher of water back there? And can you put about a little bit more water in here, please? About over, you see where it says 2,000 by 20s? Just over the top of that. Yeah. The more water that is in here, the easier it is going to be for you when you do this next part. Excuse me, sorry. But you need to leave some room in there because you're going to put this in. Thank you. So now I'm going to put my finger on the bottom of the one-hole stopper. I'm going to come over here and I'm going to keep my finger on it until I get it underneath the water. Now I don't need my finger on it anymore because, again, nothing in, nothing out, sealed with the water. But I'm going to drop this down until the water level inside the tube and the water level inside the cylinder are the same height. So if I move this, not only does the water level in here move, but the water level in here is moving as well. Changing the volume. Why? Because we're equalizing the pressures. So we lower this until we get it right to the same level. And now I need to read the volume of the gas in this collecting tube. So now I need to read the volume. Okay? And that is the volume that I'm going to take and put for the volume of gas collected. It will be in milliliters, which means eventually you are going to have to do what? Convert to liters. Once you have this volume, you're done. Take this, turn it back over. Take your 1-hole stopper out and the copper wire. Set it on the side. Take your water, acid, little bit that's left in here. Go to a sink and get rid of it. Rinse it down the sink with some water. This is now ready for your second trial. Okay? You will straighten out your piece of copper wire so that you can use it again in the next trial. Okay? Good luck. You're doing better than I am if you can get this done and straight. There we go. Okay? Ready to go. You will do the exact same procedure over again. The only thing is you will not have to make another set of qualitative observations. You're done with them. Now your temperatures of the water should be almost the same. It's room temperature. It's been out here for 3 days waiting for you. Okay? The room air pressure is not going to change. I will guarantee you the mass of the ribbon probably changes. The chances of getting 2 pieces of ribbon that are exactly the same mass are not good. Okay? Temperature of the water should be the same. The volume of the gas collected will be different. Now, the partial pressure of water vapor. Okay, you remember yesterday we talked about a mixture of gases equaling the total pressure? Well, we know what the total pressure is inside that tube. The problem is, anytime you collect the gas through water like we are doing here, some of the water vaporizes. Some of the water becomes a gas. And therefore, that gas is mixed in with the hydrogen gas. So again, I'm answering questions that are coming up later in your lab. So the gases at the top of that tube is not just the hydrogen gas, it is also water vapor. The two together, which means that total pressure, 99.25, is not just from hydrogen gas. It is from hydrogen gas and it is from water. Now, here is the unique thing about water when you bubble a gas through it. The amount of gas, the amount of pressure it creates is based on the temperature of the water you use. So if you would, go to the last page of this lab. And there is a table there. Okay? Now, this table has temperatures. And then it has pressures. So whatever temperature your water was, mine was 19 degrees Celsius. I come here, I find 19 degrees. That means the pressure of water vapor was 2.1978 kPas. 2.1978 kPas. So I am going to come back up here And I am going to write that number in this box. Why? Because in the end, for me to find the pressure of just the hydrogen gas, what do I need to do with this number and this number? You need to subtract them. This pressure is the pressure of the hydrogen gas and also the pressure of the water. So you are going to have to subtract them because all I want to know is the pressure of the hydrogen gas in there, not the pressure of both. Questions? Now, this is everything that you need to do. When you are done with one trial, you can immediately begin a second trial. Grab a piece of magnesium ribbon, put it on a balance. Take the magnesium ribbon, fold it into a U, wrap it with the copper wire. Get it set. Take your gas collecting tube, add 20 more milliliters of acid into here, pour it into here. Get the water out of your container to completely fill it. Put your magnesium ribbon, hook the wire over the edge. Put your one-hole stopper on, flip it over, begin the same thing over again. Over again. When you're done, equalize the pressures. The pressure in the tube here equal to the pressure of atmosphere out here when the water levels are equal. You get your final volume, dump this, you're done now. Please make sure you leave everything there for the next group. Put your gas collecting tube in the middle, put your one-hole stopper where they can easily find it, straighten out your copper wire and leave it there. This you can leave, this you can leave. Leave the acid, leave this. Take your thermometer, set it on the side where it won't fall into your container. Then you're done. Now you can go back and now you can start looking at the calculations. Step 1. Take the mass of the magnesium that you used and convert it into moles. So, what goes on top? 1 molar formula mass, you figure it out. Change this to be the appropriate thing. What goes on the bottom? 1 molar of the formula mass, change it to be the appropriate thing. What's the formula for magnesium? What's the formula for magnesium? Mg. Now, you need to show me this one calculation with an answer. For trial 2, you used a different mass of magnesium. All you need to do down here is show me the results for trial 2. Just the answer in moles. Don't need to show me the entire calculation again. Calculation 2, total pressure. What's the total pressure? 99.25. What's the pressure of the hydrogen gas? We don't know. What's the pressure of the water vapor? You looked it up on the last page of your lab. Therefore, you could solve for the pressure of hydrogen gas. Give me the results for your second trial. Number 3. PV equals nRT. Few things to be cautious of. For pressure, use the pressure that you calculated in 2. Use the volume of the gas, but what do you have to be careful with volume? Has to be in liters, so it's going to be a small number. We're talking 0.0 something. Okay, 0.045, something like that, 0.046. Okay? N is what we're solving for. Do not use the moles from number 1. That is what we are going to compare to later. Do not use it here. R. Which R value are we going to use over there? Which one? Okay, give me the number though. 8.31. And then temperature of your water converted into Kelvin. Do the calculation, solve for the moles of hydrogen gas produced. Do the same thing for trial 2. Now, Here's the thing about this, ladies and gentlemen. This is your reaction right here. This is a balanced chemical reaction. This is a preview of Unit 7, by the way, ladies and gentlemen. For every 1 mole of magnesium that you use, you will create 1 mole of hydrogen gas. 1 mole of magnesium will produce 1 mole of hydrogen gas. So we can compare the number that we got in calculation 1, the moles of magnesium, to the number we get in calculation 3, the moles of hydrogen gas, and we could see how well we did the lab. So you will take calculation number 3, the moles here, minus calculation number 1. Make sure you do this in parentheses to get the answer first. Then divide it by the same number you used in calculation 1, the moles again. Times 100 will give you a percent error. Remember, we did this before, a percent error calculation. We would like our percent errors to be very what? High or low? Low. Under 5%, plus or minus. Under 5%, job very well done. Plus or minus 10%, job still well done. Plus or minus 20%, job done. Plus or minus over 20%, something went wrong. But you're not graded on that. Questions? Let's get the lab done, then we'll... Let's go. Hang on. Yep, that's a fire one. Out, out, out. Let's go. This way. Come on, let's go. Let's go. Let's go. Hurry back when you're done so that we have time to get the lab at least 1 trial done. Let's go.